This is another problem, and I think this is this is of similar nature of the previous problem. Though usually I don't do problems of similar nature one after another, but today is the day. You can see here is the problem. If you can read it clearly, if you can see it clearly at your screen, an electric current, an electric circuit consists of two resistors R1 and R2 and a capacitor C. The conducting wire AB passes along a diameter of a loop of a long solenoid. Long solenoid is like this, like perpendicular to the plane of the circuit in this picture, in which the current linearly increases with time. The dV by dt equals k. So current is increasing in this solenoid, long solenoid. So what will happen? Flux will increase, and if the current is if the current is like this, then the current in this solenoid is like this, then it will produce a magnetic field in this direction. So flux of this magnetic field is increasing. That means the loops are going to become an EMF source, become EMF sources, which is going to produce a current in this direction because they want to decrease it. And to do so, they will need a clockwise current. So I guess a current will pass initially from it also. And in this direction, through this resistor, I don't know, through the capacitor, but determine the charge Q is stored by the capacitor in the steady state. So no current is going to flow through it in a steady state. And if the current flowing through R1 in the state, this is information, if the current flowing through R1 in the steady state equals I1. So this is the picture for a steady state because I named it I1 accidentally. And it seems it was given in the problem that in a steady state no current flows through this capacitor, and I1 passes through R1 and I2 through them. And what can you do? You don't need a Kirchhoff's first law. So you can dive in before solving anything else. But the EMF will be induced in the whole loop, and this loop also, left or right loop, and the whole loop. If I consider those loops as left loop and whole loop, then it's all right. And you cannot find the values of EMFs induced in this case because no area parameters has been given and you are not supposed to be God. So you can't find the values of EMF like we did in the last problem. But you can do one thing. If in this loop EMF E induced, then the whole loop 2E will be induced from the symmetry of the picture. You can do these things and you can write your equations for the whole loop and for the left loop. For the left loop, you should write this E is being used by the capacitor, and this resistance is only R1. This time wires haven't got any resistance of any kind, so that will be I1 R1 plus Q by C. This should be your equation number 1. And for the whole loop, you can write 2E equals I1 R1 plus I2 R2. These are the two equations you got. And we have 3 unknowns. And then but third unknown is absolutely not present, because the question is here, if the problem itself has an answer. If the current flowing through R1 in a steady state equals I1, a steady state, this thing will not contribute any current in it. Only current passes through these things. That means I1 equals I2. So in a steady state, I1 is equal to I2. You can find the charge Q, and the problem is being solved. So sorry for using your time for this kind of problem. You could have solved it yourself. Thank you very much for watching.